guys, so I'm back. Medyo natagalan yung ating next upload. So our topic is hydrostatic force on curved surface. So in this kind of problem, so unlike kasi sa plane surface, okay, so if we have that itong plane natin, and then yung lahat ng hydrostatic forces natin will be perpendicular sa sa isang surface at any given point. So since this is a plane, so lahat ng components ng hydrostatic force natin, kung kukunin natin siya by part, is same lang yung direction. So madali natin makuha yung ating resultant force. Okay? So unlike dito sa curved surface natin, so again, yung hydrostatic force is always perpendicular doon sa surface kung saan siya ina-apply. Okay? So like here, so naka-perpendicular tayo dito. Ito naka-perpendicular din. Okay, naka-perpendicular din. So palaki yung pressure habang lumalalim. Okay. So iba-iba yung direction nito. So unlike dito na lahat pwede mong kunin yung kumbaga isa lang yung direction ng yung component, yung angle na yan, theta. Okay, angle theta. So para-pares lang yan. So kunin mo na yung total, then that's your hydrostatic force. And this hydrostatic force have components, or has a component na horizontal and of course vertical. So same lang din dito, no? Although yun nga, magkakaiba yung direction, yung mga angles natin dyan. Okay. So ang pinakamadaling gawin is to determine yung, instead na yung isang total hydrostatic force F, unlike sa plane surface. So sa curve, sinosolve natin yung components muna before we get yung ating total hydrostatic force. Okay? Erase ko lang muna to. So paano natin isosolve yun? So here dito sa side, makikita natin yung kumbaga in-isolate natin yung imaginary volume of liquid which is directly above nung ating surface na kino-consider. Okay? So if we take a look dito sa in-isolate nating imaginary volume, so meron tayong horizontal force acting dito sa area na to. Then since kung titingnan natin, same sila. Okay, so meron tayong force din dito. So let's say this is force 1, force 1. So magkokontrahan itong dalawang to. Then we can cancel this out. So isang papuntang kanan, consider that positive. Then meron tayong papuntang kaliwa, consider that negative. Then kung titingnan natin yung let's say meron tayong width ng gate which is perpendicular dito sa screen natin. Okay? So they will have the same area. Okay? Yung kino-consider natin. Let's say ito yung ating width ng gate. Okay? So same area, same liquid. So magka-cancel out lang to. Okay? And then dito sa bottom part, so meron tayong horizontal component dito ng hydrostatic force. So let's call that FH. Okay? Then sinong kukontra dito? Of course, yung gate will react. Okay? Opposite in direction. So that is the same force FH. Okay? So kung titingnan natin, no, ano yung force FH natin dito? Okay? So that is yung ang consider natin, again, naglagay tayo ng imaginary parang vertical plane dito. So yung FH is simply equal dun sa vertical projection nitong gate natin. Vertical projection meaning kung dito tayo sa side na to, then nakatingin tayo dun sa gate. So ang makikita natin is if this is merong width W na perpendicular sa screen natin. Okay, medyo mahirap lang sa drawing. Okay, so parang ito yung nakikita natin. So that is yung vertical projection. So i-apply natin dito sa plane na to, yung solution natin sa hydrostatic force on a plane surface. Okay, which is equal to, let's say this is W, then this is, let's say, yung ating height. Uh, Tawagin na lang natin itong Y. Okay, or this is yung ating area, vertical area. Okay, so yung horizontal component ng hydrostatic force, so okay, so tulad na sa na-discuss natin sa previous video, is equal to, so yung pressure dun sa centroid, which is yung unit weight ng liquid, then yung ating H bar. Okay, so ulitin ko lang, no? H bar natin is centroid nitong area na to is sa gitna. Okay, okay, then to the liquid surface. So ayan yung ating H bar. Okay, then area natin, vertical area. Okay, so that is yung horizontal component ng hydrostatic force. So again, na-discuss na natin yan sa previous video natin. So, what about the vertical component? By the way, ano bang direction ng hydrostatic force? So, approximate muna natin na let's say somewhere dito yung total hydrostatic force F. Okay? So, meron siyang component na dito ko na lang lagay sa baba. So, meron tong component na FH, which is ito na yun. And meron siyang component na FV. Okay? So, yun yung weight. So, yung reaction ng gate, of course, will be opposite in direction. So, magre-react ngayon tong gate natin. So, mag-apply siya ngayon ng, kukontra siya ng same force FV. Then, ito nga din yung force FH natin. Okay, so what is yung FV? So, anong dinadala nitong gate? So, that is yung weight ng liquid above, in this case, above nung gate. So, dahil meron talaga siyang volume of liquid dito. So, again, solving for vertical component ng hydrostatic force is simply equal sa weight nung volume of liquid above. So, pwede natin itong i-divide into components, no? Kumbaga, mas simpleng shapes like rectangular. So, let's consider this weight 1. Then, meron tayong quarter of a circle dito. Then, that is weight 2. Okay? And then, yung total ng dalawa is weight 1 plus weight 2. So, this is equal to FV. So, paano natin makuha yung weight? Okay. So, meron tayong unit weight. Okay. So, dapat may unit weight yung liquid. Okay, so, unit weight ng liquid times yung volume. Times volume. Okay. So, paano natin kukunin yung volume? So, of course, depende sa shape. So, in this case, meron tayong volume 1, which is yung height. Height, itong, consider natin ito na length and yung width. So, meron tayong rectangular. And then, meron tayo dito quarter ng cylinder. Okay, so, parang cylindrical to shape na to, no? So, quarter nung cylinder. Okay? So, that's volume 1 plus volume 2. Okay. Then, yung application or yung location ng ating resultant is equal to, okay, so of course, yung total force muna, F is the square root of FH squared. So Pythagorean theorem lang plus FV squared. And yung direction natin, so depende kung anong reference natin. So let's say from the horizontal, okay, so let's say ito yung angle theta. Okay, so opposite and itong FH, parang nandito rin naman yung sa taas, FV, then FH. Okay, so tangent kasi opposite and adjacent yung angle natin. So that is tangent. So theta is arctangent of, opposite natin is FV over FH. Okay? So yung FH natin, so again parang plane surface lang 'to, no. I-apply natin um yung formula natin para sa kung kailangan natin i-locate yung component nitong horizontal component ng hydrostatic force. So gagamitin pa rin natin um, yung formula na yung distance E from the centroid is equal to moment of inertia about the center of gravity, okay, over area y bar. So yung y bar is yung distance along the plane, which is in this case yung vertical plane yung kinoconsider natin dito, from the liquid surface papunta dun sa ating centroid. Okay? Then, paano naman tong weight 1 and weight 2? Okay? So, ano lang tayo, no? Parang, ano ba yun? Yung pag-determine ng location ng resultant force. So, yung, let's say, meron tayong isang beam, meron tayong F1, F2, etc. Let's say F3. Then, meron tayong distance X1, X2, and X3. Then, nilolocate natin yung resultant. So, let's say nandito yung resultant force F natin with a distance of X bar. Okay? So, same lang yun dito. No? So, solve for the resultant force F location ng resultant force F. So, diba that is X bar F is equal to yung summation ng mga forces and distances X. Okay, so F1 X1 plus F2 X2 F3 X3. Okay? So malolocate natin ngayon yung resultant nitong weight ng volume ng liquid natin. Okay? So let's apply that solution dito sa ating example. Okay, i-zoom ko lang ito konti. Okay, so in this example, so nakuha ko to kay galing sa Fluid Mechanics 4th edition by Frank M. White. So a dam has a parabolic shape with an equation of so ito, z over z sub o is equal to x over x sub o squared. So parabolic, so quadratic. So as shown in the figure below. So given yung okay, so given yung XO 3 meters, so this is 3 meters and ZO 7.5 meters. Okay, so given yung unit weight ng liquid na 9.8 kilonewton per cubic meter. Okay. Then atmospheric pressure may be omitted. Okay. So compute the forces FH and FV on the dam and the position CP where they act. Okay. Okay. So we have a parabolic gate dito, no? So we need to first determine muna yung equation nitong gate natin. So sabi dito sa given sa problem that z over z sub o is equal to x squared over xo squared. Okay? So solving for z, okay? So that is equal to z sub o given naman. So meron tayong 7.5. So kung itataas na natin to doon, multiplied by x squared over xo natin. X sub o is 3 or 3 squared or 9. Okay? Then yung ating z. Okay, so we have 7.5 divided by 9. 5 over 6. Okay, so we have 5 over 6 x squared. Okay, so so we can easily solve yung ano natin, no? Horizontal component FH. So if we take this vertical projection, okay, so imaginary vertical plane. Okay, so we will have a hydrostatic force FH dito. Okay, so I hope nakikita naman yung sulat. And since this is yung ibabaw ng area na kinoconsider natin is uh, just on the liquid surface, so alam natin na zero yung pressure natin dito, and it is linearly increasing as we go deeper. Okay, so we can form a triangular pressure gradient. Okay, and we can say na if triangular yung graph ng force natin, so we know na ang location ng FH is 1/3 ng ating height. Okay, so 1/3 ng height ng gate. So if this is 7.5, then this is located sa, so this is nasa 2.5 meters. Okay, so kung i-apply natin yung formula para sa, so just to check lang, no, yung location natin, so itong height na to is, consider natin to as yung y, yung center of pressure YCP. Okay, so solving for YCP, so that is equal to I, moment of inertia, okay, over area y bar. So kapag kasi yung distance E, which is from, ito yung gitna, no, ng gate natin. So this distance E, so again, distance E is equal to ICG. Okay. So ito, yung moment of inertia natin is about the liquid surface over area y bar. Okay? So, ano yung ating moment of inertia? Pwede nyo naman gamitin kahit alin dito sa dalawa. So, you will still come up with the same result. Kung mas tanda natin yung about, yung moment of inertia about the centroid, which is BH cube over 12, so, pwede natin gamitin yon. Okay, so siguro ito na lang, no? So, mas common kasi ito. Okay, so solving for distance E, just to check if tama na tayo dito sa distance natin. Okay, so we will have B natin. Okay, so ito yung rectangular vertical projection ng gate. Ito yung axis na kino-consider natin, no? Yung axis ng moment of inertia, uh, kumbaga, is parallel dun sa liquid surface dapat. Okay, so hindi yung nakaganito. So hindi yan. Parallel dun sa liquid surface. Tayo kumukuha ng moment of inertia. Okay, so this will be yung B. This will be yung H natin. Okay, so B is given ba dito? Okay, so the width is 15 meters. Okay? But anyway, makakancel naman yung width ng B. So 15, so B, H natin is 7.5 cube over 12. Then yung area is B times H. B again is 15 yung width. H natin is 7.5. Okay? Then Y bar is kalahati nung H natin, which is 7.5 over 2. Okay? So, mata natin, makakancel lang naman yung width. Okay, so alisin natin yung isang 7.5 squared. Okay. So, 7.5 squared. Okay. So, divided by, so ito pala is tataas. Or cancel na lang natin to. Okay. 12 over 2 is 6. Okay, so times over 6 times, okay, pwede pa rin pala natin ito i-cancel. 7.5 over 6, makakancel lang din itong isa pang 7.5. Okay, so that is 7.5 squared over 6. So, yun na lang natira. Okay. Oops, wala na nga pala yung square, no? Sorry. So, that is, sorry, sinalang natin to. 7.5, na-cancel na nga pala natin yung square dahil kinancel na natin yung isa pang 7.5. So, that is 1.25. Okay. So, yung distance E is 1.25. Then, ito yung ating Y bar na kalahati ng 7.5. So, okay. 3.75. Then, plus natin yung 1.25. Okay. So, ang total natin dito is 5 meters. Then, so tama tayo na that this is 2.5. Okay? So, burahin ka muna to mga sulat natin. Okay, again, that is just to verify lang yung location of FH. Okay, so let's solve for the value of FH. So, horizontal component will be equal to, okay, so gamma H bar A. Unit weight is 9.8 kilonewton per cubic meter. H bar natin from the centroid nung area, so somewhere dito. So, ang depth natin is 7.5 over 2, which is 3.75. Sulat ko na lang para mas malinaw. Over 2. So, gamma, unit weight, H bar, then area natin. So, height, 7.5 meters times yung meron tayong width na perpendicular dito sa ating screen. So, parang papunta ron. Okay. Na 15 meters. So unit weight, H bar, area 7.5 by 15 meters. Okay, so solve natin. 9.8 times 7.5 over 2 is 3.75 times 7.5 times 15. Okay, so we will have 4,134 point. Ngayon ko na lang 38 kilonewton. So cancel naman yung mga meters natin. No? Meter is meter cube over meter cube. So cancel lahat ng length. Okay, so what about dito sa ating so that is yung FH. So paano naman yung vertical component? So somewhere dito, no? So let's call that FV. So kailangan natin makuha yung volume. Yung volume nitong liquid natin directly above ng gate. Okay? So if familiar na tayo sa mga ganitong equation, so kapag first degree yung curve natin, so straight, so linearly increasing. So ang area natin is 1/2 nung base times height. So kapag second degree na yung ating curve, parabolic, okay, so let's say this is B, H, then say this is second degree curve. Okay, so yung volume natin, area pala. So yung area natin sa triangle is 1/2 nung B times H. So kapag second degree na to, so yung area natin will be 1/3 B times H. Okay? So yung degree plus 1. Okay? So kung magiging third degree pa yan, cubic, third degree, then yung area natin is third degree, so 1 over yung degree natin plus 1. So 1/4 nung BH. Okay? So dito tayo papasok no dahil parabolic yung gate natin. So if this is 1/3 nung area nung let's say base times height, well yung base times height natin is etong rectangle na to eh. Base times height is yung rectangle. So etong portion it is 1/3 nung rectangle natin. So this portion is 2/3. Okay? So yung solving for vertical component, so unit weight natin na 9.8 kilonewton per cubic meter multiplied by the volume. So para ma-cancel natin to, maiwan yung unit natin na kilonewton. Okay, so yung volume natin is yung area ng 2/3 nung rectangle. So 2/3, then yung rectangle natin is XO 3 meters. Then yung height natin na 7.5 meters and yung width na 15 meters. Okay. Then we can solve for, so madali lang no. FV 9.8 times, so cancel na natin tong 3 times 2 times 7.5 times 15. Okay. So we have 2205 kilonewton. Double check ko lang. 9.8 times 2, 7.5, 15. Okay, so that is our vertical component. Okay, so to solve for the hydrostatic force, total hydrostatic force, F, so that is square root nung um, FH squared plus F sub V squared. So diretso ko na dito, square root of, so FH natin, okay, squared plus 2205. Okay, so exact value na lang yung nailagay ko. Okay, so we have 4, 1, oops, sorry, hindi ko na-square yung 2205. Square. So we have 4,685.625 kilonewton. Okay. So, paano naman yung location ng CP? Okay. So, nakuha na natin yung force F. So, let's determine muna yung angle from the horizontal. Okay. So, let's say nandito yung ating force F. Okay. So, let's say dito sila nag-intersect yung line. So, yung total hydrostatic force natin sa curved surface will not be necessarily perpendicular doon sa ating surface. Okay? So, kung circular yung ating surface, katulad dito sa previous example natin, if this is circular, then lahat ng hydrostatic force, lahat ng component na yan, kung di-divide natin siya sa malilit na area, okay, is always perpendicular dun sa, okay, always perpendicular dun sa mga malilit na area na yon, sa mga points na yon. So, we expect na yung resultant natin will pass through the center ng circle. So, kung dumaan siya dito sa center ng circle, then we expect na yung resultant niya is naka-perpendicular kung saan mang points tatama. Okay? But in this case, okay, so in this case na uh, parabolic yung gate natin, so hindi siya kumbaga iba-iba yung direction nga nung force natin. So wala siyang isang point na dinadaanan kung i-divide natin to into smaller areas. So yung mga hydrostatic force dun sa mga maliliit na area na yon will not have the same point unlike dito sa circular. Okay? So vertical is 2,000, horizontal is, so i-expect natin na mas pa-horizontal yung ating force. Okay. So let's say ito yung ating force F. So kailangan natin malocate itong point na to. So somewhere dito, let's call that yung ating CP. So ano yung location ng CP? Okay. So let's say this is distance XCP, then this is distance hindi siya Y, so Z CP, the center of pressure. Okay, so first is determine natin yung angle. Okay, so angle from the horizontal. So angle theta is equal to arctangent, opposite natin, ito yung opposite, yung vertical, over adjacent natin, yung horizontal. Okay? So, solve natin. Shift tan, arctangent. Okay. Opposite is FV to 205. So, ito yun. Divided by... Okay. So, we have 28.0725 degrees. So, ito yung ating angle theta. Okay. So, what's next? So, kailangan natin ma-locate muna yung... Okay. So, we need to determine this distance. Okay. And, so, ito alam na natin na 2.5. Then, this is distance, let's say distance x. X sub 1 na lang. Okay. So, kailangan natin ma-locate to kung saan sila saan yung location nitong point na to. Then, meron tayong angle. So, we should be able to determine yung location ng CP. Okay, so solve natin yung location ng CP. So, we have two lines, no? So, first is yung line of action ng total hydrostatic force F. And etong parabolic gate natin. Okay, so we have the equation of etong equation nitong ano natin. Okay, ng parabola. Okay, so 5/6 x squared. Okay, while yung equation ng line of action ng force F, so pwede natin gamitin yung slope intercept formula. So y equals to mx plus b. So the ating y-intercept. But in this case, z yung vertical natin. Okay. So, initially, at this point, okay, so we need to determine kasi yung value ng b natin. Okay. So, when y, or in this case again, z is 2.5, ang slope is rise over run, so yung vertical over horizontal. But based on this figure, alam natin na pababa. So negative 2205 over yung FH natin is 4134.38, or isakto ko muna siguro na lang 375. Okay, then yung X natin at this point is, so in this case, so hindi pa natin alam, no? Okay, plus B. So ano yung value nung X? So ano yung centroid sa itong distance x1? So ano ba yung centroid ng itong other side nung parabola natin? Ito kasi alam natin na, again, based dito. By the way, ang centroid natin pala, this is area, no? So yung centroid natin, kapag linear, first degree, so this is 2/3 ng B, then 1/3 B. Kapag naman second degree, okay, so ito 1/3, magiging ano naman to. So this is 1/4 ng B. So yung kabilang side natin is of course 3/4 ng B. Okay. So pwede nating i-derive yung yung location ng centroid nito, no? Okay, so mas familiar kasi tayo dito sa centroid nitong portion na to ng dam. Okay. So paano natin ilolocate yung centroid? Okay. Or yung centroid let's say tawagin natin itong area 2. Ito yung area 1. So moment of area. Okay, so yung total area natin uh, x bar, which is x bar times yung total area is equal to um, x1 area 1 plus x2 area 2. Pero ano yung x bar natin? So rectangular yung buong area na kinoconsider natin. So ang x bar natin dyan is yung gitna, which is um, ang area kasi natin by the way is area natin is x times z. Okay. So area natin is xo then z sub o. Then yung x bar natin is xo over 2. Okay? So this is equal to, so yung x1a1, itong area 1, ito na pala yung tawagin kong area 1. This is area 2. Okay. So ito ngayon nahanap natin yung x1. So ano yung area 1? Ito. So nakuha na natin yan dito na if this is second degree, this is 1/3 nung base times height, then this is 2/3. Okay. So x1, which is yung unknown, area natin is 2/3. Okay. So by the way, dito tayo nag-moment no about this axis. Okay. So 2/3 ng base natin is x sub o, z sub o. Base times height. Okay. Plus, ang x2, a2 natin, ang x2, ito na nga second degree. So this is 3/4 nung base. Okay. So 1/4 to, then 3/4 to. Okay. Again, pag triangle kasi 1/3, 2/3 pagka second degree. So yung denominator natin dito nadadagdagan isa. So yung 1/3 nagiging 1/4, then this will be 3/4 sa kabilang side. Okay, so we have 3/4 nung XO. Okay, sa yung moment arm. Then yung area natin is, okay, so area naman ito. So that is 1/3 ng B times H. 1/3 ng B natin is XO. Height natin is Z sub O. So lahat merong XO. Tigis ang XO. Alisin ko to. XO. XO. Okay. Then yung area natin, yung Z sub O. So lahat ng terms natin, puro may Z sub O. So pwede nating alisin. Okay. So pwede nating simplify sa XO over 2 is equal to, this is 2/3 x sub 1, yung hinahanap natin, plus, okay, so this is 3/4 ng XO, 3/4 ng XO, plus, times 1/3, so para maka-cancel na tong 3, so plus XO over 4. Okay, so i-regroup lang natin yung mga XO. So this is XO over 2 minus XO over 4 is equal to 2/3 ng X sub 1. Okay, so 1/2 minus nung 1/4 is 1/4. So So, makuha natin dito is x sub o over 4. Then, pag ita-transpose natin ito, magiging numerator. Ito magiging denominator. So, times 3 over 2 x1. So, yung distance x1 pala is 3/8 ng x sub o. Okay? Which is equal to, this is 3. Yung x1 natin is 3. So, magiging 9/8. Okay? So, this is 9/8. Okay, so let's solve for the value of y-intercept p. Okay, so we have 2.5. So magiging plus pag tinranspose plus 2205 times 9 divided by 4135.375. Okay, times 8. Okay, so we have 3.1. So, yung formula or equation ng line natin, nung line of action of force, is equal to, gawin ko itong z, no? Itong y. Z is equals to, ang slope natin, again, negative, pababa, 2205 over 4134.375. Okay? Then, variable pa rin tong x plus 3.1. Okay, so kailangan natin makuha yung point of intersection kay nitong parabola natin and yung line of action ng force. So, kung meron pa rin tayong calculator na pwedeng mag-solve ng equations, so pwede natin i-combine yung dalawang equations na to, no? Okay? Okay, so we have yung equation ng parabola natin. So, balikan natin dito. So, we have 5 over 6x squared. Okay. So, z is equals to 5 over 6x squared. So, dalawang equation. So, pwedeng i-subtract natin to. I-subtract natin. Okay. So, magka-cancel na ngayon yung z. Then, this will be 5 over 6x squared. So, magiging positive ngayon to. Plus 0.5 over 4134.375 x. Then, magiging minus 3.1. So, ito pwede natin itong i-input sa Casio to determine yung root natin para sa x. So, dalawa yung makukuha natin value. Kasi kung titingnan natin dito, yung equation ng parabola, pwede naman siya dumiretso dito sa kabilang side. So, dalawa yung point of intersection natin. Okay. So, pag inequate natin or combine natin yung dalawang equation, okay, so, makukuha natin yung point of intersection. Okay, so, pwedeng gamitan ng calculator ng Casio. So, makukuha natin sagot. Or, dito kasi sa akin, meron akong, okay, so, this is a graphing calculator. Okay. So, ilalagay natin dito yung dalawang equations natin. Okay. So, f of x, so, yung z natin is y. So, this is 5 over 6 times x squared. Okay? Then, yung second equation natin, okay, so, ito naman yung linear na equation. So, that is negative 2205 over 4134.375. Okay? Then x plus 3.1. Okay, so yan yung dalawang equation sa nakaselect. So, ipa-plot natin yung graph. Okay, so ito ngayon yung ating graph, no? So, ito yung location ng CP. So, pwede kong tingnan dito yung point of intersection. Okay, so enter ko lang yan. Okay, so we have 1.635. Okay, so that is yung value ng x. While yung value ng y, or in this case nga pala is z. So that is 2.228 meter. So that is from the bottom of the gate. Okay, so mula dito. ZCP and XZP. Okay, so that is our first example para dito sa curved surface. So medyo challenging na to kasi parabolic yung ating curved surface or ating gate. So for the next video, our second example, so mas simple ng konti nun dahil we have here a curved circular. Okay? So circular yung curvature ng gate natin. Pero ang difference is yung liquid or yung water natin is under nung ating gate, hindi siya above. So kung titingnan kasi natin, sabi natin yung vertical component ng hydrostatic force is simply equal to the weight nung liquid directly above nung ating gate. But in this case, wala naman tayong liquid directly above. Okay? So, if you like this video, so medyo mahaba, so please consider to subscribe. So talaga ang goal ko is to cover many subjects in civil engineering. Okay? So, in the near future, medyo wala lang akong ganong karaming time sa ngayon. Okay? And subscribe, then enable natin yung notifications para maging updated tayo, no? And malaman nyo na-upload ko na yung ating solution para dito sa next example. Okay, so see you again and have a good day.